was covered in block 1. So usually you will get at least one out of these three. So if you go through these three, there is a gamma multipole radiation and selection rules, or beta spectrum, and Gamow theory of alpha decay, or beta's Fermi's theory of beta decay. So out of these three, if you take up one, that is completely, that is sufficient from this alpha, beta, and gamma. And next one is you have elementary particles. And here the important topic in this is you have a conservation loss and exact conservation loss and approximate conservation loss. And you have other how the charged particles, they interact with matter. So in this, you have interaction of heavy charged particles and Bohr's formula and Bethes modification. The Bethes modification, that is minus d by dx. And in this, you have a many short answers. So here, short answer questions, stopping power and range energy relation. How the range of a particle in a given medium, how do you define the range? So that is the average distance traveled by the particle before it loses its complete energy. That means it comes to a rest. That is the range of a particular particle. So that we define as a distance traveled by particle before it loses its complete energy and come to a rest position, and it is represented by capital R, and that will be given for a different alpha particle, that capital R is equal to 0.318 into 10 to the power of minus 2 e to the power 3 by 2. Okay, so that is the range. Even if it is a proton of energy, then R is E by 9.3 to the power 1 by 8. So in this way, you can calculate that empirical relations and you can estimate the relative range in a particular material. So if the different mass number, if mass number differs, then range also differs. So that's why capital R rho by under root A, that is equal to constant. So that is one important for range and energy and stopping power and branch long and straggling. These 4 topics are important for your short answers. So straggling also is another important parameter. So usually while computing a range of a particle in a particular medium, so that means usually it follows a certain straight path. After traveling a certain distance, it will, what will happen? It will passes a zigzag path, and that the range will be less than actual distance it traveled. So it will follow a zigzag path, but the total distance may cover more than what it traveled. So that distance. So that means you will have some fluctuations in the energy loss by an ion in each collision. After colliding with a air molecule or whatever that material it passes through, it will loses its energy by a small fraction. So that collision per unit length. So the stopping process of a particle in a medium is of a statistical. It is a statistical nature. So what will happen? Spread in the observed range. So whatever that monoenergetic particle, if you consider, its range, observed range. So you will have a spread. So this phenomena is called range straggling, and that usually you will plot with a number of particles uh, and the distance. So the distance and number of particles in the uh, penetrating beam of a particle. So that is the plot that will give you the range straggling. Similarly, energy straggling also you can plot. So, and Bremsstrahlung, this Bremsstrahlung is due to a small mass of a beta particle. Sorry, this yeah, that's beta. So that goes a deflection through much larger angles while colliding with the atomic electrons. So while it is colliding with atomic electrons, it will be deflected at a wider angles. And that is a two colliding particles. Uh, if they are identical, they will exchange. So this type of exchange phenomena also will happen. And the beta particles, usually they will travel with a very high speeds, and the reflective effects must be considered in the collision mechanism. So this type of a small fluctuation, that energy, there is a difference minus dE by dx, that is the stopping power, is much smaller. So that electrons are more penetrating than the heavy ions. The heavy ions, they cannot penetrate much distance in the matter. So, 1 MeV electron in an aluminum, almost it travels about 1800 micrometers, when compared to that it will travel a 3 micrometer of an alpha particle. So electron with 1 MeV and with the almost same energetic alpha particle, it will travel only 3 micrometers, whereas electron can travel almost 1800 micrometers. So that is in comparison with how the heavy particles and light particles, they travel in matter. So that electron accelerated in this manner, so radiates energy, and which we called as a Bremsstrahlung radiation or energy. So there is a fact that all the accelerated charged particles radiate such type of energy, but very high energies, the electron lost most of its radiation. So this is you can explain on the basis of quantum mechanics, and it is completely developed by Bethe using the Dirac relativistic theory. So using that, you can how you can explain the Bremsstrahlung with a quantum mechanical treatment, and you can calculate the energy E is equal to, that is the E naught, initial energy, into e to the power minus x by L. So that is a capital L is equal to 1 by mu, which is a constant. So mu is called a linear absorption coefficient. Mu is called a linear absorption coefficient, and from that you can molecular absorption coefficient and others also you can calculate. So that's why the interaction of how the alpha and electron will, while passing through the matter, electron will penetrate much more distance when compared to the alpha particle. So then the straggling is whatever the particle is passing through a material, it will follow a zigzag path, and that is the actual range. It is more than the actual range because it will travel in a zigzag way. And while computing this the energy loss, so you will have a small fluctuation, and you can find a spread in the observed range. Range is not particularly fixed. So you will have a small fluctuation in the range that we call it as a range straggling. So these are all some of the important short concepts which are very, very essential for your understanding of the nuclear physics. Okay. So after that, you have how the gamma they interact with the matter. So this is a charged particles, alpha or a beta are charged particles. Alpha is a heavily charged particle, heavily not charged, that's a heavy massive particle, while electron being a high speed particles. So are beta particles. So they are of high speed particles. So they interact with the matter differently, while gamma radiation, it interacts differently. So here you can measure the classification, how the gamma rays interact with matter. So one is photoelectric effect, second one is the Compton scattering, and third one is the pair production. Okay. So it depends on the available energy. You can find different ways how the gamma ray will lose its energy. So Compton scattering and photoelectric effect, and another one is the pair production. So these are the three important concepts. And in the pair production, you will have a concept of negative energy. So usually, according to classical theory, there is no such concept of negative energy, but quantum mechanics explains the existence of negative energy states. So that is for using the relativistic quantum mechanics, explained by the Dirac negative energy states. So these are the important concepts what you have to go through from this unit 5. Okay. After that, you have a radiation detectors. The radiation detector means, so whatever the radiation present at any environment, or if it you are using some alpha source or a gamma source or some other X-ray source. So different the radiation after interacting with the matter, it will come out. So in what direction it is coming, or what is its intensity, and what type of a radiation is present in that particular interaction, so that you have to observe. So for observe means with a naked eye, you can't observe the radiation. So here we call it the radiation detectors. So the detector will detect the what type of a radiation, what is its energy, and so in your graduation already you have studied this bubble chamber and cloud chamber, many other detectors. So that means the detectors you can classify based on the ion collection, and no ion collection. That means it is not based on an ion collection. Also, you have some detectors. So in the ion collection, you have a saturation collection or uh, multiplicative ion collection. Under multiplicative ion detectors, you have a proportional counters. Under proportional counters, you have in a one range, you have a GM region. So within that GM region, you have a GM counter. So in the laboratory, usually you will be working with the GM counters with a linear absorption coefficient and a half-life of a long-lived substance and other statistical estimation, or you can have the half-life and also GM characteristics. So there are 4 to 5 experiments which we can uh, perform at degree level. So after that, you have a based on the ion collection, you have a saturation ion collection. So under that, you have it is in gas or in semiconductor detectors. Okay. So under non ion collection based, you have a counters such as light based on the light emission. So that is Cherenkov counters and scintillation detectors. So based on the light emitted from the radiation, if it hits some material, it will emit photons. By counting those photons, you or light, you can get the energy and intensity of the particular radiation. So Cherenkov and scintillation detector comes under this. And other one are you have a image streaming or image forming devices. You have a spark chamber and bubble chamber and cloud chamber and photographic emulsion techniques. So these are all the different techniques. Under this, we have a scintillation detector, which comes under a light collecting uh, detectors. So that part is a scintillation detector. Any radiation hits a sodium iodide activated with a thallium, it will give a photons. That photoelectrons will be multiplied by a successive photomultiplier tubes, which are given a successive increase in the voltage. So at the end, you will get a small pulse that will be fed to a preamplifier. Then it will be connected to a amplifier and voltage discriminator, and you have a scalars, single channel analyzer and multi-channel analyzer, and you can connect to a data acquisition system such as a computer or any other such a system, and you can monitor through computer, or you can change the voltage setting, the lower discriminator and upper discriminator, and you can set for a window so that you can get the only a radiation with a particular energy you can scan from the 0 to till the end of it. So there are many other options available with the main component is a photomultiplier tube. Okay. So and here the important one is the uh, scintillator. That scintillator, what type of a candidate is good for a scintillator? So here sodium iodide activated with thallium. So that part is important for your uh, so sodium iodide activated with a thallium is usually generally used scintillator. Apart from that, you have many other organic scintillators as well as inorganic scintillators, such as the BGO and that is you have other organic scintillators or stillbane and other organic scintillators. So their emission wavelength is a particularly is suitable for a particular wavelength, and time constant and other thing parameters you can use, and from those things you can choose the better organic scintillators. Okay. So after that, you have a solid state detector. the solid state detectors also, you have a diffuser junction detector. That means you have a PN junction detector, and another is a surface barrier detector. Surface barrier detector, or these are the two solid state type of detect solid state.
Excuse me, sir.
Yes.
Sir, are you sharing your screen?
Technically, I am expecting you not visible. 1 minute. Here, I'm expecting you to participate. What are the topics here? Just already whatever I covered in the previous sections, those things I am briefly reviewing. So if you have any doubts, then we can go through particular topic. Otherwise, I will give you the general what is yeah. So here, as per our discussion today, I wanted to give you the brief idea how to prepare for your theory exams. So if you participate, what are the important topics that to be covered? I am going through that part.
Okay, sir.
Yeah. Hello, is it clear? So today, technically, I opened this complete session for discussion. So if you have any general doubts, you ask about this block 1 to block 5. And already I shared the PPT of yesterday's NMR.
Yes, sir, we got it.
Hello.
Yes, sir. You can proceed, sir.
Yeah, but briefly, by explaining these things, usually it is very difficult to assimilate at this junction. So that means what I mean to give a brief discussion about this each block. So that will you choose what are the different blocks you want to prepare in detail. So the block 1, block 2, block 3, and block 4 and block 5. Block 5 is the resonance spectroscopy, and it consists of NMR and NQR and ESR. So that NMR, yesterday we covered that NMR. So in the NMR, you can expect block equations and or NMR spectrometer. Those are the important. And even NQR also, NQR spectrometer, similarly ESR spectrometer. These three important topics you can cover. So if you come to block 4, you have already we covered the phase contrast microscope and TGA and other DSC. These are the two block 13 and 14. Block 13 and 14. So here in this, you have a photo phase contrast microscope and SEM and TEM, 3. And unit 14, you have thermogravimetric analysis and DSC. And unit 5 and unit 16 completely covered the Mossbar effect. So what is the theory and Mossbar spectrometer, and you have a isomer shift. So in the NMR, you have a chemical shift. Here you have a isomer shift. So there is a small comparison between these two, and how you will calculate the isomer shift using Mossbar parameters and chemical shift, that is the chemical environment around proton. It gives you that's a from NMR. So these are all too important for your structural and other determination of a chemical compounds and further other structural details. So that's why you can choose block 4 or block 5. If you are choosing these two, these are the important topics that is to be covered. So again, the unit 3. The unit 3, you have a nuclear reactions. So all these PPTs regarding each and every, almost the last 10 PPTs, I shared some of the PPTs. If you require any other PPT, you can request in the group, so that I will post that particular PPT regarding. So almost for the last 8 classes, we have different PPTs prepared for each topic. So nuclear reactions is another important completely
Sir,
covering
can
the
you share all one PPT already shared?
yeah.
Other 7 PPTs you can
Today
share
also I
that
shared one
in
PPT.
chat box, sir. We
Yeah.
can proceed for that, sir.
Last time I shared 2 PPTs that I don't know what PPTs I shared.
Only we got one PPT, sir. Yesterday PPT only we got it.
The
Other
first
one we didn't get, sir.
last time I shared at the class itself, similarly like this.
Question
Okay,
papers,
anyway,
one time we have to share, sir. Question papers, previous question papers.
question papers you have, no?
Yes, sir.
Already I shared question papers.
Question papers already shared, sir.
Okay.
But only one PPT we get, sir. We got.
Okay, that I will share in your WhatsApp group.
Yeah.
Not may not be in this one. Other
In chat box we have to share, sir. We can copy that link and we
right
get.
now. Hello.
Okay, sir.
Yeah, that
Okay,
I will
sir.
share. So in the nuclear reactions, important one is a Q of a reaction. What is a Q of a reaction? And derivation. The derivation already long back I shared the this one written material, no? Already I shared this type of a Q of a equation. This I shared long back in the class itself, and other Fermi age equation, and other 3 or 4 topics I shared in the class, the physical papers. Okay. So that Q of a reaction is important. The definition and the Q, if it is a positive or if it is a negative, how the Q, how do you derive? Derivation part and the solution. Derivation and solution. That Q equation, usually, how do you define a Q equation is, it is a analytical relationship between the nuclear disintegration energy, capital Q, and kinetic energy of the incident and product particles measured in the lab coordinates is called a Q equation. So if the Q is a positive, it is an exothermic or exoergic. That means it gives the energy out after the reaction. If Q is a negative, it is an endothermic reaction. Okay, endothermic or
Excuse me, sir.
Yes. Sorry. Yeah, tell me.
Screen share aవ్వట్లేదు.
Here it is a completely what I am giving you is the it is a overall picture of complete course 5. So these already I shared in the other PPTs. Right now I am not sharing. That is just briefly I am giving you what the importance of particular topic in the block. So in the block 3 you have different type of nuclear reactions and conservation laws and definition of a Q equation and Q equation derivation and its solution. So it is very important. Next, you have a neutrons. Neutrons, how do you classify neutrons on the basis of their energy? So you have a slow neutrons, fast neutrons, thermal neutrons, and ultra fast neutrons, very fast neutrons. So that's a slow neutrons also you can classify on further, that is the epithermal and resonance neutrons. And the thermal neutrons are important for nuclear fission. So thermal neutrons are of 0.025 eV. Neutrons are called as a thermal neutrons. So these are the important concepts. Okay. Another one is in this nuclear reactions, we have a compound nuclear theory also. That compound nuclear theory, briefly, just compound nuclear theory. Okay. And basic properties of neutrons and how the neutrons will lose their energy while passing through the matter. So there are three important not derivations, there are concepts. How do you calculate the neutron loss? Using logarithmic energy decrement and moderating ratio and slowing down of neutrons by neutron diffusion. So neutron diffusion and logarithmic energy decrement and moderation of ratio, moderating ratio. So these three important concepts. So that how the neutron loses its energy within a thermal reactor, and finally if it reaches uranium, you will have a nuclear fission. So how to control the nuclear fission? And that is a continuous slowing down model and Fermi age modification, that is Fermi age equation. And finally, that four-factor formula. Four-factor formula is what are the four important factors that determine the nuclear fission. So if K is equal to 1, that is a sustainable chain reaction. If multiplication is more than 1, you will end up with an explosion. If K is less than 1, the nuclear fission ceases. So that no more nuclear fission takes place. So that we are not interested. Even if it is a K is more than 1, you will get a explosion. That also we are not interested. Only the sustainable chain reaction, if K is equal to multiplication factor, K is equal to 1, the chain reaction continuously goes on for a long period under controlled atmosphere, that is attaining a critical condition or a critical size of a nuclear reactor. That is the main part of your nuclear fission reactors. So this is the important concepts what we covered in the nuclear reactions. So if you come to block 2, you have these are the basic properties of a nucleus. So how do you define nuclear radius and what is the mass? and what is its density. So this is the densiest matter present in the complete universe is the nuclear density and binding energy. So that what is the binding energy per particle? That is 8 MeV on average. The binding energy per particle is 8 MeV. So other basic properties, you have a nuclear statistics and parity and angular momentum and magnetic dipole moment and electric quadrupole moment and electric dipole moment and electric quadrupole moment. So the quadrupole moment is it gives you the quadrupole, that is a deviation from the spherical symmetry. So the charges will accumulate in the four corners. So that deviation from a spherical symmetry. So this because of this electric quadrupole moment, you can define the molecule as an oblate spheroid or a prolate spheroid. Prolate spheroid is your Earth is a model if it pressed at the poles and it will be bulged around the equator. So that is a type of a oblate spheroid, and prolate spheroid is if you press around, apply pressure around the equator, and if you elongate along the poles, you will get a vertical one, that is a prolate. So the prolate spheroid and oblate spheroid, all these we discussed in the previous sections. So these are the important or basic properties of a nucleus. These you can expect for a short answer. So magnetic dipole moment, electric quadrupole moment, and parity statistics. These are all of a short answer. And next, if you come to nuclear forces, so here you can expect a very essay question, that is a two-body problem. So that a two-body problem, that is a theory of deuteron. So that is you can expect for an essay, and other rest all are short answers. So exchange force, meson theory of nuclear forces, tensor forces, all these completely you can expect for a short answer. So if you come to nuclear models, you have a single particle model and collective model. So that means a collective model, liquid drop model supports the collective behavior of all nucleons. So they behave collectively. So that is a liquid drop model. And if it is an independent particle model, you have a shell model. So shell model and liquid drop model are of two different concepts. But the shell model is not going to explain all the properties. Similarly, liquid drop model is also not going to explain all the properties. These two, it depends on the situation we need. So you have a compound nuclear theory and nuclear fission. You have to explain only on the basis of liquid drop. And other small other unpaired unpaired nucleons will contribute to the properties of nucleides that completely you can explain on the basis of shell model. So you can choose what topic you are confident out of the block 2. So already block 1 I explained. We have a radiation detectors and this charged particles, how do they interact with a matter, and neutral gamma, how do they interact with the matter while they pass through the material, and elementary particles and gamma radiation and multiple radiation, gamma radiation, and beta theory, that is a Fermi's theory of beta decay and Gamow theory of alpha decay. So usually you can expect more questions from the block 1 always. So more than 2 short answers and more than 2 essay questions from block 1. That is a general tendency. Okay. So this is what I want
Sir,
to
can
convey.
you share the PPT of block 1, block 2, block 3 link in the chat box, sir?
Yes, I will try to share. Yeah. Yeah. So that right now I will try to share one or two. Again, I have to check with the folder and I have to put it in the Google Drive. Then I will share. Yeah, that is the my problem at right now to share all the PPTs. If it is not possible to share within this class, I will share within the group, or you can send your phone number in the chat box. Then I will share to personally 1 or 2 people so that you can share.
Excuse me, sir. No,
Yeah.
sir, in the group, sir, please.
Yeah. Then I will go to the chat box and you type your name and phone number so that I can share with those people. You can share what later.
Excuse me, sir.
Yeah.
In the group, please share in the group, sir.
In the
These people.
that group, 1 minute.
Also group, sir.
WhatsApp group only. Okay. Yeah. Anything you want to convey? ఇంకేదైనా ఉంటే మీరు చెప్పండి.
Sir, I can share my phone number and name. You can send to me
Lakshmi,
personally. No? Yes, sir. I will send that all PDF in the WhatsApp group. It is useful to all, sir.
Yes. You need PPT or PPT only, no? PPT or yeah.
Yes, sir. Block 1, block 2, block 3 PPTs I can share, sir.
Okay.
Thank you, sir.
What else? So out of these, you can choose block 1, block 2, block 3, block 4, block 5. So need not prepare all the. So as a teacher, I should not tell like that, but you can choose accordingly your convenience and you can prepare for this exam. Yes. Any specific doubts ఏదైనా ఉంటే మీరు అడగచ్చు. Then I will leave and all the best. And you can call me at any time for your general any doubts. Okay.
You can share the PPT, sir.
No, right now it is not possible. I will share. Yeah.
Okay,
So they
okay,
have to put in the Google Drive direct.
Okay.
Yeah. Then only I can share.
Okay,
So
sir.
it will take time and I will share.
Okay, sir. Okay, sir. Thank you, sir.
Bye. All the best.
Thank you, sir.
This is the last class, sir. No more classes for that.